All right, let's look at the definition of arc measures. All right, let's look at minor arc. All right, so minor arc is it's going to be an angle. So say angle A or B, and it's the arc subtended or intercepted by that angle. So we're looking at the angle here. From here, I mean the arc. So we're looking at this arc. So when we say the measure of arc ACB, so we're going to use C so that we're not talking about this arc. So ACB is that arc. So measure of the arc is defined by, if you have a minor arc, it's going to be defined by the corresponding measure of the central angle. Central angle is, so measure of the angle AOB, right? So this angle right here, right? So if you have a semicircle, so if you have a measure of, say, arc ACB, right? So we're looking at the arc from here all the way around to the other side, right? Then if you have a semicircle, then arc is going to have a measure 180, right? It makes sense, right? In a way, you have a straight angle there, so angle measure is 180, which we are not allowed to use 180 in this book, but it makes sense to have a arc measure 180. All right, then major arc is actually I put C on the wrong place. Actually, C is going to be on the other side. So if you look at it, angle AOB, C is actually sitting on the outside. So we are talking about the major arc, which is this arc right here. So here is the arc, right? If that's the case, we want to define the measure of the arc ACB to be, right, 360 minus measure of the angle AOB, right? We couldn't just use the measure of the central angle because it only goes up to 180, not including 180. But we want this major arc to have a larger measure. So what we're gonna do is 360 minus the measure of the angle AOB, right? So that's how we define the measures of arc, minor arc and semicircle, and the major arc. Right? There's theorem 1 which talks about the additivity of arc measures. Alright, so this is a kind of a tedious check because there's a case where you have a minor arc, but if you add two minor arcs, you might end up with another minor arc, or could end up with major arc, and so on. So we have to look at a bunch of cases, but the proof is fairly straightforward. So I'm going to just state this theorem. Alright, so if you have a big arc, ABC, which can be split into two arcs here, APB, and the other one BQC, where the union is gonna create a larger arc ABC, and the intersection is only one point, B. B is the only intersection point, right? If that's the case, measure of the big arc ABC can be split into just the measure of the arc APB plus measure of the arc BQC, right? So we can split the measures of arc into two parts, and if you only have one point in common, right? That's it. I hope that this was clear.